Welcome to CS Digest, and in this video we will be studying about a new form of finite automata, that is non-deterministic finite automata. We can call it as NFA and DFA and NDFSM, anything we can call. This is non-deterministic finite automata, non-deterministic finite automata, and this is non-deterministic finite state machine. We can call anything. Okay, so as we studied in our previous video, here NFA can be described as a 5-tuple that is same as before: Q, sigma, delta, Q naught and F, where Q is the set of non-empty finite set of states. In NFA, sigma is non-empty finite set of input symbols, delta is the transition function, and Q naught is the initial state of our finite state machine, and F is our final state or non-empty final state. So here our transition function will be described as Q into sigma union epsilon. This gives 2 power Q, where Q is power set of Q or set of all subsets of Q. Okay, now let me take an example to explain this. For example, Q is equal to Q0, Q1, Q2. Okay, so power set of this would be, first it will contain all these elements, that is Q0, Q1, Q2. It will contain Q0, Q1. It will contain Q1, Q2. And it will also contain phi, that is an empty set. So this you will study in discrete mathematics, that what is the power of a set. If you know this, then well and good, but you will study this thoroughly in discrete mathematics part. But in short, what is power of a set is, you note down all the possible sets that is contained in this set. Okay, so if you define an NFA, so what is an NFA is, suppose it is sometimes difficult to decide the next state uniquely by the present state and the present input symbol. So such machines are called as NFA. So in NFA we cannot decide the next state uniquely by judging the present state and the present input symbol. That you will understand when we will design an NFA in further videos. One thing to note down is that here epsilon, lambda, or this symbol, these are known as null string symbols. Okay, these are null string symbols. Secondly, final states are not compulsory for DFA and NFA. As long as their conditions are satisfied, it can be DFA or NFA without final states also. Okay, and one very important thing is, every finite automata is NFA but not DFA. All these statements you will understand when we will design our NFA and DFAs. Till then, you can just understand this theoretical part. The practical part we will study as we go further. Okay, so this is all about NFA. Now coming on, our next important thing is the next type of finite automata. It is DFA or DFSM. Okay, deterministic finite automata or deterministic finite state machine. Here also it is defined using 5 tuples, that is Q, sigma, delta, Q naught and F. All is same. Q is our set of non-empty finite states. Okay, our sigma is non-empty finite set of input symbols. Q naught is our initial state. F is our final state, and delta, that is transition function in DFA, is defined as Q into sigma gives Q. So in DFA, every state will be defined for every input symbol. Okay, here every state will be defined for every input symbol, and at every state for every input symbol our output state must be single. Okay, for example, if this is our initial state, this is our final state Q1, and this is our another state Q2. So we will have to define, for example, we take 0 as our input symbol. 0 is our non-empty input symbol. Okay, this is our initial state. So on 0 it will go to Q1, on 0 it will go to Q2. So here you are saying that on 0 Q0 is going to multiple states, which is not valid. Because for every input symbol output state must be single, but here it is going to multiple states, which is not valid. Okay, now let's take another example for this. Suppose we have Q0, Q1, Q2, and let's take this as our final state. Okay, so suppose on 0 it is going here, on 0 it is going here, on 0 it is going back to Q0, or on 1 it is going here, and Q0 on 1 is going to Q2, and Q1 on 1 is remaining on Q1. So here sigma is our two input symbols 0 and 1, and for condition 1, what does condition 1 says? Condition 1 says every state will be defined for every input symbol. That is, here every state is defined for every input symbol. Our input symbol is 0 and 1. So for 0 it is defined, yes. For 1 it is defined, yes. Q1 for 0 it is defined, yes. For 1 it is defined, yes. For Q2 0 it is defined, for 1 it is defined. So condition 1 is satisfied. Now coming to condition 2, what does condition 2 says? For every input symbol output state must be single. Okay, so here on 0 it is going to Q1, and on 0 it is not going to Q2. Okay, so it is not going to multiple states on one input symbol. Similarly, you can check for another input symbols also. For example, in Q1 on 0 it is going on Q2, it is not going to Q0 or to Q1, so it is going to a single state. So our condition 2 is also satisfied. So this is how DFA works, and if both these conditions are satisfied, then it is known as a DFA. But these conditions are not mandatory in NFA. Okay, so let's take a question. Suppose this is Q0, this is Q1. Okay, on 0 it is going here, on 0 it is going back, on 1 going here, on 1 remaining here. Okay, so is it NFA? We see here Q0 is the initial state, but there is no final state. So is it an NFA? Yes, it is an NFA because there are no rules to design an NFA. But is it a DFA? No, it is not a DFA. It is not a DFA. Are you sure? Wrong. It is a DFA as well. So that is a trick here. It is a DFA also. Why? Because our both conditions are satisfied in this question. It doesn't matter if there exists a final state or not. For DFA we have to check our two conditions we discussed. So on one input symbol it is going to only one state, and every state here is defined for every input symbol. So both our conditions are satisfied for DFA also. So this is NFA also and DFA also. Okay, remember this, because lot of students do a mistake here. They mark it as an NFA, but they don't mark it as a DFA, which is incorrect. Okay, so from here we can note two important points. First one, every DFA is NFA, but reverse is not true. Okay, similarly for every NFA there exists an equivalent DFA. Okay, so if an NFA is given, it doesn't mean that it is a DFA as well. Okay, but if a DFA is given, then it is also NFA. Okay, so that's all about NFA and DFA. From the next video we will be doing a question on this, and then we will moving further in our next lectures. Okay, thank you.